Appendix C, Part 236, Safety and Assurance of the Criteria Process. Whatever the purpose of the appendix provides the safety criteria of the process for the designer and user develop and validate with the product with the means of the safety requirements for this part of the FAA issue for the criteria for the process set forth in the appendix to evaluate the validity of the safety target with the result of the system safety analysis provided with the RSPP, PTSP, and the PTCI, PPCDB, and PTCSP's documents appropriate for the analysis performed under this appendix address each of the safety principles of paragraph B of the appendix explained which are not relevant and to employ the validation verification process pursuant to paragraph C of the appendix. B. The safety principle must be followed during the product's development. With the designer shall address each of the following safety consideration principles of the design, demonstrating that the safety product with the coverage with the part H and I of this part. In the event of any of these principles are not followed by the program safety plan with the positive train control deployment plan or positive control safety plan, shall the state represent reason for the departure for the alternative utilized to mitigate with the eliminate with the hazards associated with the design principle not followed. 1. Safety systems under the normal operation condition systems of all the elements, including the hardware software, must be designed to ensure the safety operation of no hazards of the events of the not anticipated operating conditions with the proper inputs within the expected range of the environmental conditions. All safety critical functions must be performed properly under the normal conditions. The system shall operate safely even with the absence of the prescribed operative action. The designer must identify the category all the hazards that may lead to the unsafe system operation. Hazardous categories are unacceptable, which are determined with the hazardous analysis must be eliminated with the design. Most efforts shall be all be the same. Also be made with the designer would eliminate the design hazards categories undesirable hazards that cannot be eliminated shall be mitigated with the acceptable level that is required by this part. 2. The system safety under failures. It must be shown that the product is designed to eliminate, mitigate the unsafe systematic failure of the condition can be attributed to the human error that could occur with the various stages throughout the product of development. It includes the unsafe errors in the software due to the human error of the software specification, design, coding of the phase of the human error of the code could impact the hardware design. Unsafe conditions that could occur with the improper design of the human-machine interface for the installation, maintenance errors, and errors associated with the making modifications. 2. The product must be shown in the operating safety of the condition with the random hardware. Failures of these include single hardware failure with these multiple hardware failures that may occur with a different time with the remaining undetected in Latin with the react with a combination of the substantial failure with the later time that can be unsafe with an operating situation. In the instance involving Latin failure with the subsequent failures similar to those between the signal failure and the event of the transit failure is designed the system should be restart itself if they do so. Frequently attempted with the restarts must be considered in the hazardous analysis required by the statute 236-907-8D 88. A8. 3. There should be no single point failure for the product that can result with the hazard category as unacceptable desired occurrence of the credible signal. The point of failure that can result with the hazard must be detected with the product must be achieved with the known safety active state with elimination of the possibility of the falls of the activation of any physical appliance. 4. If non-self-revealing failure combined with the second failure can cause the hazard to the category as unacceptable, the undesirable second failure must be detected with the product must be achieved with the known safety of the elimination of the possibility of false activation of any physical appliance. 5. Another concern with the multiple failures involved with the common mode of the failures in which two or more subsystems components intended to compensate with one another to perform the same function all fail with the same mode with the result in an unsafe condition. This is particular with the concern in the instance of the two or more elements, hardware and software, both are used with the combination to ensure safety. If the commonly made failure exists, analysis performed in the appendix cannot rely on the assumption of the failure that are independent. Examples include the use of the redundancy in which two or more electronic elements perform the given function or pair well with one hardware or software element, check of the minors another element of the hardware and software to help ensure the safety of the operation. Common mode that relates to the independence which must be ensured within the instance when the dealing with the effect of the hardware failure of the design should be derived for the effect of the failure not only for the other than the hardware but also execution of the software, since hardware failures can be greatly affected with how the software operates. 3. Closed loop principle. System design adhering to the closed loop principle to require the additional all conditions necessary for the existing with any permissive state and action to be verified with the present before the permissive state action be initiated. Likewise, the request of a condition shall be verified to be the continuous present with the permissive state action to be maintained. This is in contrast along the permissive state with the action initiated with the maintained with the absence of the detected failures. In addition, Closed-loop design requires the failure to perform logical operation in the absence of the logical input-output. The decision should not be the cause of the unsafe condition, i.e. the system safety does not depend on the occurrence of the action of the logical decision. 4. Safety assurance concept. The product design may include one or more of the following safety assurance concepts that described in the IEEE 483 standard to ensure the failure to detect that the product is placed in the safe state. When one or more of the different principles are applied with the individual subsystem components depending on the safety design object of the part of the product. Design diversity of self-checking concept. The concept requires that all critical functions may perform the diverse using the diverse software operations and or the diverse hardware can handle the critical hardware to be tested with the self-checking routine. The permissive outputs are allowed only if the result of the diverse operation correspond with the self-checking process reveals no failure of the other either execution software and any other monitored input-output hardware. If the diverse operation does not agree with the checking that reveals critical failures and safety critical functions output must be the default of the state and known state safe state. 2. The check redundancy concept. The check redundancy concept is required for the implementation of the two or more identical independent hardware units with executing identical software performing identical functions. The meaning of the provide with periodically compare the vital parameters resolved with the independent redundant units, requiring agreements of all compared parameters to serve with the maintained permissive output. If the units do not agree, safely critical functions and outputs must be the default known as safe state. 3. The end version of the program concept. The concept requires the processor base for the use of at least two software programs performing identical functions with executing concurrently when the cycle of the software programs must be written with an independent team that is using different tools with multiple independent written software programs can compromise the redundant system may be executed. Redundant system may be executed with either separate hardware units which may do not be identical within one hardware unit by the means of the provided with the compare with the result of the output state for the multiple redundant software systems. If the system result do not agree with the system critical function for the output with it must be default is known as safe state. 4. Numerical assurance concept. The concept requires the state of each of the vital parameters of the product service system uniquely represented with a large encoded numerical value, such as the permissive result with a calculated pseudo-randomly combining represented numerical values that each of the critical constitute the parameter for the permissive of the decision with the vital algorithms must be entirely represented by data structure for the containing the numerical value with verified characteristics. Non-vital decisions are to be made with existing software only by the numerical representation themselves, and in the event of the critical failure, the critical functions outputs must be default and known as safe states. Step 5. Intrinsic fail-safe design concept. The intrinsic fail-safe hardware circuit within the system of those that employ with a discrete mechanical and or electrical component of the fail-safe operation product subsystem. The design to use the principal concept required the verification of the effect of every relevant failure mode of each of the component with the relevant combination of failures mode of the conservatively analyzed documented with a typical perform with the competent failures mode of the effect for the analysis or FMEA. Which must be shown with the residual unmitigated failures in the event of the criteria critical failure of the safety critical functions output must be default known as the safe state. 5. Human factor engineering principle. The product design must be simply incorporated the human factor of engineering with the appropriate complexity of the product with the educational, mental, physical capabilities intended with the operator maintained with the degree of the required human interaction with the component with the environment and with the product will be used. 6. System safety under the external influence. The product must be shown to operate with safety will be subject to different external influences including electrical influence such as power supply anomalies, transit and abnormal improper input and conditions outside normal range input relative to the amplitude and the frequency and unusual combination of the inputs including the related human operator without other such electromagnetic interface with electrostatic discharge both. 1. Mechanical influences such as vibration and shock. 3. The climatic conditions such as temperature and humidity. 7. System after modification safety must be ensured with the following modifications: hardware, software, and both or all systems. Some of the concerns that identified with the paragraph must be applicable depending on the nature of the extent of the modification. Such modifications must follow all the concept of the implementation test process of the principles documented in the program safety plan for the original product. The regression testing must be comprehensive, documented, and included all scenarios which affect the change mode of the operating of the modes of the changed product during the normal and failure state with the fallback operation. C. What standard for the acceptable verification validation. The standard for the employed with the verification or validation or the both of the product subject with the subpart must be sufficient to support achievement of the applicable requirements to subpart H and subpart I of this part. U.S. Department of Defense Military Standards or MIL Standard 888 2C System Safety Program requirements, January 1993, recognized the providing appropriate risk with analysis process within incorporating within the verification validation standard. The following standards designed for the application of the process-based signal training of the control system are recognized acceptable with respect to the applicable elements of safety analysis required for the subpart H and subpart I of this part. The latest version of the standard list below should be used unless otherwise provided, i.e. standards as follows: 1483-2000 standard for the verification vital function of the processor-based using the rail transit control. 1474.2 to 2003, the standard for the use of the interface requirement of the communication based on the train control or CBTC system, i.e. 1474.1 times 2004, communication based on the train control personal performance function and requirements CBTC or CENEELEC standard files. EN 50129 Railway Application Communication Signals Processing System Safety Related Electronic Systems and Signals. In Phase 50155 2001 and A1 2002 Railway Application Electronic Equipment using the rolling stock ATCS Specification 200 Communication System Architecture ATC Specification 250 Message Formats ARIMA 2009 Communication Signal Manual Recommendation Practices Part 16, 17, 21, and 23. 6. Safety High-Speed Ground Transportation System Analytical Method. The Safety Validation Computer Control Subsystem Volume 2. Development of the Safety Validation Method. The final report with Subpart 1995 author IEC 61508 International Electrotechnical Commission Functional Safety Electronic and Programmable Electronic Safety Related Systems IEC 61508-1 Part 1 General Requirements of IEC Cordium Part 1 General Requirements IEC 61508-2 the parts requirements for the electronic program electronic safety related systems. Software requirements for the IEC 61508 software requirements 61058 IEC Part 4 definitions abbreviation correspondence Part 5, example of the method for determination safety integrated levels. Example of the method for determination safety integrated levels. 61508, 6 part guideline for the application of the 61058 2 and 3. 61057, overview of the techniques and measures. IEC 62278 2002, railway application specification demonstrated reliability, availability, maintainable systems or RAMs. Railway application software, railway control protection system, use of unpublished standards, including proprietary standards of the unauthorized extent with the standards shown but achieve the requirements of this part. However, each standard shall be available for inspection and publication of the FRA public examination, public procedure for FRA to which they are relevant. Various standards provided with the paragraph illustrated purpose of the copy of these standards to be obtained in accordance with the following. U.S. government standard for the technical publication to be obtained with the containing of the Federal National Technical Information Services 53001 Shawnee Road, Alexandria, Virginia, and through 22312. The United States standard may be obtained with the contacting the United States American National Standard Institute, 25 West 33rd Street, 4th floor, New York, 136. IEC to be obtained with the contacting International Electronic Technical Commission with the rule of the VMAR, P.O. Box 131, Chapter 1211, Geneva 20, Switzerland. Your technical standards may be obtained with the contacting one of the national standards body with the makeup of the European Committee for the Electrical Technical Standardization. The IEEE standards may be obtained by the contacting the IEEE publication official with 1066 to Los Vegas, Circle the P.O. Box 3014, Los Alamos, California 90720. 1264. American standards may be obtained from the American Railway Engineer Maintenance of the Way Association. 1003 Deerwick Lane Suite. 2010 210 Lanham, Maryland 20706. Appendix D to Part 236 Independent Review of the Verification and Validation.